Greetings. In this video I'll be talking about the fundamental counting principle. So if you choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is m times n. So basically that would be like this. You've got two spots to fill, and if you are going to fill the first spot with an item from one group, let's say for instance, I've got 3 pens here. So I'm going to pick one of my pens, and then I have maybe 4 different markers, and so I'm going to choose one pen and one marker. And so the fundamental counting principle says if I want to know the total number of choices, well, in this first position I have 3 items for which I can choose, and in the second position I have 4 items from which to choose. So all in all, there are 12 possibilities here. So that's the basic idea behind this fundamental counting principle. So let's look at some other examples of where we can use this. So the model of a car that you're thinking of buying is available in 9 different colors and 3 different styles. In how many ways can you order the car? So we have 9 different colors, 3 different styles. So there are 27 ways that this can be ordered. In a second scenario, it says, in how many ways can a casting director choose a female lead and a male lead from 5 female actors and 6 male actors? We're going to choose one from this group and one from this group. So we have 5 options and 6 options. Altogether, there would be 30. So next it says you are painting parking spaces with a letter from the alphabet and a single digit from 1 to 9. So for instance, the parking space labels would look something like this, either A1 and Z9. How many parking spaces can you paint with distinct labels? So we would have 26 options for the letter of the alphabet, and then there are 9 options here when we're thinking about the digits from 1 to 9. So all in all, we have, let's see, 26 times 9, and that's 234. So the nice thing about this counting principle is it can be extended. So in each of these examples, I was just choosing one item from each of 2 groups. And but if we have multiple groups, as long as we're just pulling one item from each of those groups, then this can be extended. So let me show you an example. So a pizza can be ordered in 3 sizes. So we have 3 different sizes. With one of 2 crust, you can have thin and crispy or traditional. So far there were 3 options for the size, 2 options for the crust, and there are 6 toppings available. You've got sausage, pepperoni, onion, bell pepper, mushrooms, and banana peppers. How many 1-topping pizzas can be ordered? So we're just going to choose one of these 6 toppings. So we have 3 times 2, which is 6, times 6. There would be 36 1-topping pizzas available. Now, if there were some other option besides the size, the crust, and the topping, like maybe you could order had your choice of cheese. So instead of just having 3 different factors here, you could extend this with more and more factors as long as you're just pulling one item from each group. All right, so that's the fundamental counting principle.